Okay, let's get going. Today is 6:25. This is video number 143, and it's about the assignment I gave you yesterday to do. And we look here at problem number 1, number 2, number 3 that you might want to have in front of you when you're working. And we have to map out a strategy before we start doing these, okay? So I look at number 1. And the 3 terms here are coprime. There's no one number I can take out. So I look at it and I realize that this is a problem about factoring. If I factor this and I factor this, I'll probably be able to cancel and name a restriction. So the strategy is the same. They want you to see the pattern principally of perfect squares. So if you look at number 2, you'll be looking at perfect squares. And I told you at the beginning of the year how important perfect squares are. So there we go again. And they want you to use your factoring techniques and factor, cancel, name restriction. And that pretty much sums up what they want you to do. Factoring can be as difficult as you want it to be. So I look at number 1, and the top guy must be factorable. I'm thinking to myself, the bottom guy is definitely a perfect square trinomial. Okay, I should be able to spot that. But the top guy is going to be a little extra work. These guys always are. 2 times -2 is -4. Again, I'm presuming it's factorable, right? And, oh, there it is. 4 times -1 equals -4. So I'm good there. You're supposed to be able to do that. They presume you can do that. It's irritating enough you can't do it right away, but they presume you're going to work it out. So that's what you're supposed to do. Okay? And I'm leaving out the 1, and I'm rewriting the 2, and I'll just draw the line. So this would be step number 2. There's room for mental math here. Come on. You're supposed to recognize it. They think you're supposed to be able to do that. I won't write the square because I'm anticipating canceling. So here we go. We work this one out. This turns out to be 2x. Let's see. 2x times x plus 2. There it is. That's what we're matching there. You see it going ahead. And what's this over here? -1 makes it go x plus 2 again. Okay? So we write, and again, there's room to skip these steps. I get that. Okay? And finally, we write it out on the bottom here. Hopefully, we're working okay. Yeah. Put it down just a little bit here. And I get 2x minus 1. Again, some of you might say you're working it out too much, but I'll keep going here. And there we go. And that's what we are anticipating in problems like this. So reduced form, simplified form, and I'll write it over here on the side here and then erase, is 2x minus 1 divided by x plus 2. Okay, everybody see that? No, you can't. I'm blocking it. Okay? And the restriction will be x cannot equal -2. I won't do that again and again, but they'd expect you to say the excluded value is -2. All right, so let me go on to the next one. And I'll erase everything, give myself room to write. So, all right, so there I cleaned up some space, and I'm going to do the second one, okay? And there we are, focused on number 2, and again, perfect square, a plus in the middle. You're expected to recognize that configuration, okay? And sure, we could work it out. I showed you how to do it the long way, but that's not their purpose. So this is going to be 2x square root of, or 2 minus 3 times 2x plus 3. Okay? So this becomes this. There's the bar. And you're expected to recognize the second perfect square over here. And 2 times 3, I'm taking the square roots and I'm doubling it, gives me 12. So with all the confidence in the world, I know that the square root of 4 is 2. And this is just a perfect square trinomial that you're supposed to be able to get, recognize. There's the cancel that you'd be expected to do. And now with our answer over here, which I'll turn our answer over here, I just wanted to do one of these. What's left, in other words, what didn't cancel, is this rational expression. And now they ask you to find the restriction. So let's write that out, since the restriction can be a fraction. Okay? And I'm just doing 8th grade math here, of course. And I get 2x does not equal -3. So there we go. This is the restriction, of course. And the answer, of course, is x cannot equal -3 over 2. Okay? So there's a case where we're accepting rational numbers, fractions, something to think about over there. Okay? And now I go on to the third one. How's my time? I'm doing great on time. I take a look at that one, turn the camera over here, and erase. And now we're ready to finish up this third problem, which again is just blending, or if you like, giving us a chance to review the math that we learned through our assignments and the lectures. So here we go. Again, what's the game? It's got to be reducible, otherwise they wouldn't give it to us. You notice that 2 can be extracted out of the whole thing. I won't do it that way. I'll do it another way, but it turns out to be the same thing. Mine is a little easier to understand. So what do 18 and 2 share? Sure, they share the 2. Well, we were expecting that because 18 and 2 aren't perfect squares. And if there's no perfect squares appearing here, be tough to reduce. And remember, there's no guarantee you can simplify. It's just these problems are about that topic. Okay, so what's left here? 9x squared minus 1. Well, there you go. You probably expected it. Perfect square, perfect square. Draw the bar. You don't want to get confused with all this math. And what can you extract over here? The 4 is the maximum, but 4 goes into 36, 9x squared times. Well, that should have your brain working already, right? And over here, 4 goes into -24, 6x, -6x times. And finally, of course, 4 goes into itself one time. Perfect square, same order. You see, it's like a game. And you've got to be able to break these things down, recognize most of them were perfect squares. When they're not, like we saw in the first problem, it's a lot more work. I'll turn the camera a little more to the center now and finish off the problem. So I'm going to keep the 2 and the 4 and save that till last. But 9x minus 1, 9x squared minus 1, square root of 9 is 3. I take the negative and I take the positive. So you're expected to do that. What can I say? You expect it anyway, because otherwise you won't be able to reduce. Okay? And now keep the 4. We'll deal with that. We know that 2 goes into 4. We'll reduce that in a second. And the same idea, but the middle term is negative. So it has to be 3x minus 1 squared. And this is what kids would end up doing. I mean, you kill yourself working out every problem, every step of the way, right? And now we cancel what we can. These cancel, and this becomes 1, but 1 times anything is itself, and half of 4 is 2. So what's left? Well, 3x plus 1 is left on the top, okay? And 2x times 3x minus 1 is left on the bottom. And so there's the answer, the simplification, so to speak. Now, what's the restriction? Well, that's something we could handle in class to even talk about a little bit. But the restriction is 3x minus 1 cannot equal 0, because 2 times 0 is 0. I can ignore the 2. I'm only looking for the restriction. I'm not asked to distribute or anything like that, right? So there it is. Okay, so here we go. I do the math. Don't want to take forever doing the math there. And x cannot equal 1/3. Negative 1 becomes positive 1 divided by 3. And there you go. There's the excluded value. The restriction is above. And the problem is complete. And this gives you a good idea of what they'd be asking you to do. Okay? So we'll get the next 3 problems in the next video. And there they are again. And like I said, you can always pause these things. Okay?